Welcome to this explainer. Today, we're taking a fascinating, completely data-driven look at this massive planetary shift that scientists call the Anthropocene climate regime. Now look, if you follow science news at all, you've probably heard a lot of doom-mongering or panic around this topic. But we're going to set all of that completely aside today. Instead, we're focusing strictly on the mechanics of our planet. We're going to use clear, structured facts to understand what this new climate era actually means, what the evidence is literally showing us right now, and why it completely reshapes how we need to think about our future.
Okay, let's dive right into this with a pretty stark reality. Earth is simply no longer operating under the conditions that shaped human civilization. It's a heavy statement, right? We're not just talking about, a couple of hotter summers. We are talking about a total system-wide transformation. The absolute baseline rules of the environment, the exact same rules our ancestors used to build the first cities, invent agriculture, and expand across the globe, those rules have fundamentally changed. And to really wrap our heads around where we're going, we first have to understand exactly where we just came from.
Which brings us to Act 1, the Great Disruption. And honestly, the end of the stability we've enjoyed for millennia. So for the last 10,000 years, Earth has basically been cruising in what geologists call the Holocene epoch. You can think of the Holocene as this planetary Goldilocks zone. It wasn't too hot, wasn't too cold. Global temperatures just stayed within this remarkably narrow, stable range. And because of that amazing stability, around 5,000 years ago, we got predictable monsoon systems. We got consistent rainfall. And predictable weather meant predictable crop yields. That single fact allowed humanity to invent agriculture, settle down, and build massive, complex cities. Literally, our entire modern infrastructure, our food systems, our coastal cities, our power grids, they were all perfectly custom-built for this specific 10,000-year window of deep climatic stability. But then, just an absolute blink of an eye ago in geological terms, roughly 150 years ago, that incredibly long period of stability was completely interrupted by a rapid industrial transformation. Just think about the sheer speed of this disruption. Back in the pre-industrial Holocene, carbon dioxide levels just kind of hovered around 280 parts per million. That was the magic recipe for our stable climate. Today, in the Anthropocene, we are pushing past 420 parts per million. Now, in geological terms, shifts like this usually take tens of thousands of years to happen. But through massive fossil fuel combustion, industrial agriculture, and clearing out forests, we've basically executed this massive shift in just 150 to 200 years. It is an absolute whiplash for the Earth's systems. We fundamentally alter the atmospheric chemistry that regulates the entire planet's temperature.
So, you might be wondering, how do we know this isn't just some far-off future prediction? Well, let's transition to Act 2, Proof and Mechanics, and look at the actual observable evidence of this new era.
The evidence that we're already in a transformed state is totally undeniable, and it comes from dozens of independent data sets. We're not waiting around for this to happen, it is happening right now. Our baseline global temperatures are rising with recent years just continually smashing historical records. And the Arctic? The Arctic isn't just warming, it's literally warming up to 4 times faster than the rest of the globe. And because Earth's weather is one giant, interconnected machine, that intense warming at the poles acts like a massive amplifier, completely destabilizing weather patterns everywhere else. This leads directly to what we're actually experiencing on the ground: heavier, way more destructive rainfall events in some areas, while at the exact same time, other regions are just trapped in longer, absolutely punishing drought periods. These extremes, they're becoming the new baseline.
But honestly, here is perhaps the most staggering realization of all. When we talk about global warming, we naturally think about the air, right? Because that's where we live. But over 90% of the excess heat trapped by our emissions is actually being absorbed and stored by our oceans. Just let that sink in. Only a tiny fraction, around 10%, is going into the atmosphere, the land, and melting the ice. Our oceans are basically acting as this massive, planetary heat sponge. It's a phenomenal accumulation of raw energy, and it perfectly explains why ocean heat content just keeps breaking records year after year after year.
Now, because of all that stored energy, we really need to talk about a scary buzzword that gets thrown around a lot in the news: irreversible. In public discussions, irreversible sounds like the end of the world, right? Like there's no hope. But in climate science, irreversible simply refers to timescales and system inertia. It just means that certain physical changes to the Earth are completely locked in for centuries, or maybe even millennia. It absolutely does not mean humanity is doomed, but it does mean we can't just flip a magic switch tomorrow and instantly return to the climate we had in the 1990s.
Let's break down the mechanics of this inertia. Think of the climate like a massive, incredibly heavy cargo ship moving at top speed. Even if you completely cut the engines right this second, that huge ship is going to keep gliding forward for miles just because of its sheer momentum.
Well, our planet works the exact same way. A huge portion of the CO2 we emit today is going to remain in the atmosphere for hundreds, if not thousands of years. And those oceans we just mentioned, they absorb heat slowly, sure, but they also release it incredibly slowly, which locks in warming for generations. Our massive ice sheets in Greenland and Antarctica take centuries to fully respond to temperature changes, meaning sea level rise is practically locked in. And even forest ecosystems take centuries to adjust. So this is exactly what scientists mean by irreversible. The momentum is already carrying the ship forward on our human planning timescales.
Okay, let's move to Act 3 and see how this builds into something even more complex as we examine the accelerators, tipping points, and feedbacks.
One of the biggest concerns in modern science right now is crossing what we call tipping points. These are basically thresholds where a system gets pushed so far that it suddenly shifts into a completely new state, and the changes become non-linear. They just take off. The major tipping elements we're watching include the potential collapse of the Greenland and West Antarctic ice sheets. There's also the real risk of the Amazon rainforest experiencing a severe dieback, transforming from this lush, incredible carbon sink into a dry savanna. And then we have thawing permafrost, which remarkably holds about twice as much carbon as is currently in our entire atmosphere. We're also closely watching the potential weakening of the AMOC. That's the major ocean current that completely regulates the climate of the Northern Hemisphere. The real danger here is that once triggered, these systems might just keep changing all on their own, even if humans completely stopped every ounce of emissions.
Let's look at the mechanics of just one of these shifts, the ice albedo feedback loop. It's literally a chain reaction. Step 1, warming causes us to lose our bright white sea ice coverage. Step 2, well, because there's less white ice to reflect the sun's rays, way more solar radiation gets absorbed by the dark ocean water that's left behind. Step 3, that darker water absorbs the heat, causing even more regional warming, which leads directly to Step 4. That extra heat melts even more ice, and the whole cycle just starts all over again. One change heavily amplifies the next in a continuous, self-reinforcing loop that rapidly speeds up the overall transformation of our climate. Now I know, hearing about tipping points and feedback loops can totally make it sound like things are spiraling completely beyond our comprehension. But it is absolutely crucial to know this. Most observed warming still falls entirely within the upper range of scientific model projections, not outside them. Sometimes you'll read headlines saying that climate is changing faster than expected. Usually that's just because real-world emissions ended up being higher than certain assumptions, or natural variability layered on top of the long-term trend. But the core physics, the supercomputers, our scientific models remain incredibly robust and accurate. We know exactly what is happening, and we know exactly why it's happening. So, what does this actually mean for us? Let's pivot to Act 4, the new reality, and look at everyday life in the Anthropocene.
We're shifting away from global mechanics and into our daily, lived reality. Look, these aren't just distant projections for the year 2100. This is literally what is happening outside our windows today. We are already seeing food production instability because intense heat and drought are constantly stressing our crop yields. Arid regions are facing incredibly severe water scarcity. We're unfortunately documenting rising mortality risks directly related to extreme heat waves. Our power grids, our roads, our bridges, they are experiencing unprecedented infrastructure stress from extreme weather that they were simply never designed to handle. And ultimately, all of this economic and environmental instability creates intense, climate-driven migration pressures, which disproportionately affects the most vulnerable regions worldwide. This is exactly why understanding these mechanics matters to every single one of us.
So the crucial point to take away is this. While a full reversal to the nice, stable climate of the 1800s isn't an option on our timescale, limitation absolutely is. We still have immense agency here. We can still slow the rate of warming significantly by rapidly cutting our emissions. We can absolutely limit the peak temperature levels the planet ultimately reaches. We can dramatically reduce human suffering through infrastructure adaptation, building smarter, way more resilient cities. And we can research and heavily deploy carbon removal technologies to help manage those long-term concentrations. The scientific consensus is incredibly clear on this. Every single fraction of a degree of warming that we avoid matters immensely. Every ton of carbon kept out of the atmosphere literally saves lives and ecosystems.
Which leaves us with the defining question of this new era. The Earth system is no longer in equilibrium. The shift to the Anthropocene, it's locked in. The real challenge of our century isn't debating whether or not the climate is changing, it's answering this. How extreme will this new climate era become, and how quickly can humanity stabilize it? The laws of physics have dealt their hand, but the severity of our future is still very much within our control. It's a massive challenge, for sure, but with a clear-eyed understanding of the facts, it is one we are fully capable of taking on. Thank you so much for joining me for this explainer, and keep learning.